Good day. My name is Raymond Jerome R. Pigaw, and I will be presenting to you roller chains. Roller chains or chain drive. They offer improved efficiency and used in mechanical drive components. Roller chains are used in many applications, from conveyor systems to motorcycles. Compared to belts that are suitable for systems with low to moderate load, roller chains are for heavy-duty applications because of their higher load bearing and torque capacity. The materials used for roller chains are steel alloys and hard carbon steel. These are the commonly used, these two. For the next two, roller link and link plates. These are basically parts of the roller chain, which are heat treated. For the next slide, this gives us the types of roller chains: simplex, duplex, triplex, double pitch chains, heavy duty roller chains. Starting from simplex. Simplex is the most common type used in wide range of applications including bicycles and motorcycles. For the duplex, these chains have two rows of rollers increasing their strength and load carrying capacity. Same for triplex. These chains have three rows of rollers offering even greater strength. For the double pitch chains, these chains are designed for slower speed and lighter load than standard chains. For heavy-duty roller chains, these chains are typically have thicker side plates for added load capacity. Advantages and design considerations of roller chains. Roller chains have high power transmission, precise synchronization, durable, efficient, and compact. For the design consideration, roller chains starts with chain selection, sprocket design, chain length, and lubrication. Chain should be selected for the proper application regarding with the sprocket design. With the chain length, chain tension should be adjusted. For the lubrication is part of the maintenance of the roller chain. Roller chains can transmit significant power, making them suitable for demanding applications. They also provide accurate synchronization between the driving and driven components, crucial for applications requiring precise timing. Roller chains are made of metal, making them suitable for use in harsh environments, including those with oil, grease, or abrasive materials. Roller chains have high transmission efficiency, often reaching up to 98%. Compared to belt drives, roller chains can occupy less space in width. For the disadvantages and common failures of roller chains, starting with the maintenance. Roller chains require regular lubrication and maintenance to ensure optimal performance and longevity. They can be noisier than some other drive systems. Chain drives can experience velocity fluctuations, especially when the chain is stretched. The common failures for roller chains are wear and fatigue failure. The uses of roller chains. Roller chains are extensively used in industrial machinery for power transmission and material handling. This includes applications like conveyors, printing presses, and machine tools. For the automotive industry, roller chains are used for engine timing systems. Also, roller chains are a key component in conveyor systems, moving materials and products in various industries. They are used to transport items horizontally, vertically, and even to drop items into trucks. For the formulas of roller chains, for solving with the distance between the center adjacent rollers. These are the formula for the pitch diameter of the large sprocket and small sprocket is equal to the pitch of chain over sine 180 over the number of teeth. For the length of chain, 2 times the center distance plus number of teeth of the small sprocket plus number of teeth of the large sprocket over 2 plus large sprocket minus number of teeth of the small sprocket squared over 40 times center distance between sprockets. For the outside diameter of the small and large sprocket, the formula is the pitch multiplied by 0.60 plus cotangent 180 over the number of teeth of the sprocket given. For the center distance between the sprockets, the formula is equal to pitch over 8 multiplied by 2 times the pitch minus number of the large sprocket minus number of the teeth in the small sprocket plus square root of the length times 2 of the chain minus the number of teeth of the large sprocket minus the number of teeth of the small sprocket squared minus 0.810 multiplied by the number of teeth of the large sprocket minus the number of teeth of the small sprocket squared. These are the practice problems. Starting from number 1, a chain and sprocket has a 24 teeth with a chain pitch of 1/2 inch. If the sprocket turns at 600 rpm, find the speed of chain. For the speed of chain, we'll be using the formula of speed of chain multiplied by the pitch times number of teeth times rpm. For directly substituting, we'll get the answer of 7,200 inches per minute. In converting it to feet per minute, the answer will be 600 feet per minute. For number 2, a chain and sprocket has a pitch diameter of 28.654 inches and there are 90 teeth available. Find the pitch of the chain. Using the formula of the pitch diameter is equal to pitch of the chain over sine 180 over the number of teeth. The given are diameter of 28.654 inches and the number of teeth of 90. The pitch of chain gives us 1 inch. For number 3, a chain with speed of 800 feet per minute has a driving sprocket turns at 900 rpm. If the pitch of chain is 3/4 inches, find the number of teeth of driving sprocket. Using the same formula as number 1, the number of teeth is 14.22 teeth. For number 4, find the standard distance between sprocket having 4-inch and 16 inches diameters. So for the center distance, we'll be using the center distance formula of diameter of the large sprocket plus diameter of the small sprocket over 2 is equal to 16 plus 4 over 2. Then the center distance will be 18 inches. Number 5. A sprocket with 8 inches diameter and a pitch of 3/4 inch drives another sprocket at standard center distance of 48 pitches. Find the diameter of the large sprocket. With the given of the pitch of chain, we'll be using the formula of the center distance all over the pitch of chain. With directly substituting, we'll get the diameter of the large sprocket of 32 inches. These are the additional practice problems. A certain farm equipment which requires 2,200 Nm torque at 500 rpm has diesel engine to operate at 1,500 rpm as its prime mover. For a number 60 roller chain with a total length 60 pitches and a small sprocket of 23 teeth are to be used, with operating temperature to remain constant at 45 degrees Celsius. Determine the number of teeth of the larger sprocket. Number 7. A chain of ordinary proportions. The term RC40 means a pitch of. Number 8. A motor transmits 40 horsepower to an air conditioning apparatus by means of a roller chain. The motor runs 720 rpm. The pitch diameter of the sprocket on the motor should not exceed 6 3/4 inches. If the drive calls for a service factor of 1.2 and the chain pitch of 1 inch, determine the number of teeth of the small sprocket. Number 9. A 10 horsepower engine with a speed of 1,200 rpm is used to drive a blower with a velocity ratio of 3:1. The pitch diameter of the driven sprocket is 85 mm and the center distance between the sprockets is 260 mm. Using an RC40 drive and a service factor of 1.2. Find the number of teeth of the driving sprocket. Number 10. Find the chain speed of an RC80 chain on a 21-tooth sprocket turning at 600 rpm with a torque of 21 Nm. Thank you for listening.